First, we'll hear for the experience of some people who did science. And the first on the list is Professor Nancy Haegel in physics. She's from Department of Physics in the Naval Postgraduate School. And she's a Fulbright Senior Scholar Fellow now in the Hebrew University of Jerusalem. It's great to have you here, Nancy.
Start while he's setting that up. That's an interesting segue with the last line being physics as the last holdout. That is my field. Although I started in materials science, and you saw the trajectory there. So I want to start, if it's okay to begin? Okay. I certainly want to thank Professor Messer-Yaron, the Fulbright Commission, my host at Hebrew University, so many of the people that have made this evening possible. And my stay as a Fulbright scholar at Hebrew University possible. It has been all I had hoped for and more. And I'm glad that it's not quite over yet. We don't go home until December 29th. So if you want to invite me to any other universities, I'm enjoying visiting as many of them as I can. I've been part of outstanding scientific work. I've met a lot of other faculty. The cultural exchange and discussion has just been outstanding. And I really hope that it has fulfilled the dreams of those, starting with Senator Fulbright after World War II, all the way to Neil now and his staff that make Fulbright possible. So that's the first thing. I also want to acknowledge the individual hospitality of so many people since I've been here, who have invited me into their homes, have endless discussions about traditions and religion and culture and history and the latest conflict in Israel. I have learned a tremendous amount, and I am deeply grateful for all of that. Do I have how do I work from here? Okay, very good. I'm especially pleased with the content of the symposium because it balances, I think, the two things that we do need. And Nancy Hopkins made evidence or mention of it. Hagit mentioned it as well. We need scholarship on the topic. We need good data, we need good analysis, and we need personal experience and reflection, right? We need both of those. So the data, I think, are important because you have to really ask the hard questions, examine your own preconceptions and things like that. And it's good to listen to people's stories because they tell you things sometimes that the data won't. So those are two important things. But it's important, I think, to realize that personal experience is always local, or I like the word particular, right? So when I relate my experience, you have to do it with that clearly in mind, that it is really the particular experience of one person, right, who was born at a particular time, came of age in a particular time and place, and had a very personal experience. Alone, it's probably of fairly limited value, I think. But when you combine it with the experience of many other people, as they did at MIT, and then with really good scholarship and data, again, as they did at MIT, then you start to have important information and really move forward. I want to start by taking just a couple minutes to talk about my scientific interest, because that is a large part of why I'm here. I titled the slide, Seeing with Different Eyes, Thoughts on Science, Women, and Women in Science. That's what I try to do in my research, and I'll tell you briefly about that. It also captures, though, I think, a little bit about Fulbright, what Fulbright's about, and being elsewhere, and seeing with different eyes, and about women in science. So my research focuses in the idea, really, that this phrase, a picture is worth 1,000 words. And if you think historically, we've had major changes when we've been able to see things that we couldn't see before. We were limited, and so historical examples would include the telescope, tremendous breakthrough when you could see the kind of detail in the sky. More recently, the scanning tunneling microscope, which affects my research, being able to see things that are very small, thermal night vision, being able to see at night, so seeing things that our eyes don't, so sort of keeping that in mind. I started my work in infrared astronomy, not as an astronomer, but as someone who built detectors for the astronomers. And when you do infrared astronomy, you're interested in things like early stars, the evolution of the galaxies, atomic emission, interstellar dust, topics that things we can't learn about from visible astronomy. Just because there's a lot of scientists in the audience, I wanted to give you a sense of where you are. So infrared astronomy means wavelengths, of that range, energy, frequency. Again, hopefully you have one you can pick. And I love this picture. These were my students at Fairfield University who obviously had a little too much time on their hands and went out and made the world's most famous equation on the graphs. So, the top is a visible image of the center of our galaxy. And you notice the dark band. There's dust there. There's dust that obscures our ability to see into the center. And you can sort of take that as an image, right? There are things that get in our way of seeing. Sometimes it's tradition, sometimes it's our history, sometimes it's our personal experience. The lower picture shows the view of the center of the galaxy in the far infrared, and you see right through the dust. So it's worth looking in other parts of the spectrum. My detectors were launched. This is what I did as a graduate student, and in my early days, they were launched on this satellite in 2003. And see, and now see if this works. But this is going to be a picture of the launch in the infrared. So we know what it looks like in the visible. In the infrared, you don't even see the rocket. You just see the hot gas that it leaves behind, right? You get a whole nother picture of the exact same event. So the satellites went up, or the satellite went up into space, the detectors went up into space. My particular part, not to get into too much detail, was to understand the transient response of detectors. The photon signal, the light, might do something like the top. You'd like the detector to do the middle, but real detectors operating in space at 3 Kelvin do what's down below. So my early work was trying to understand that, and when we could understand it, we could model it. This shows modeling and simulation and experiments that we did that show how the electric fields change inside the detector. Once we did that, we could take a signal like this is what the light would do, and know that the detector would do that. And the astronomers could then work their way back and get a more accurate picture of the sky. More recently, I've moved to a very different scale of things. I work on nanomaterials, nanoscience, the things that will become our lasers and detectors of the future. And just for reference, in the bottom picture, these are microscope pictures, 65,000 times, 260,000 times. I study materials like this. I have an area called transport imaging, where I use 3 different microscopes at the same time: a scanning electron microscope, an atomic force microscope, a near-field microscope, and this is where Professor Lewis's group is one of the most outstanding groups in the world. That's what brought me here, was to work with them. We combine those and we literally take pictures of how electrons move. So we're going to make electrons in a material in the center of that picture. We're going to apply an electric field to slosh them back and forth, and we literally take pictures. So you can't really see an electron in this way, but I have a way to kind of see the light that electrons emit. So that's what keeps me busy. We do it in nanowires. We do it in looking at, this is light coming out of a nanowire. This may be your laser or solid state lighting of the future. My goal here is to do it inside of solar cells, to literally take a solar cell like you see here. These are called multi-junctions. You use different parts of the solar spectrum with different cells. These have the world record for efficiency, 44%. They're very expensive, but we've learned a lot in doing them. And my goal in Israel was to see if I could see electrons move inside a cell. And so I've done a lot of work looking at electrons moving in the layers this way, and that's the pictures you see here. But now my goal is to do it in cross-section, to literally break the cell and look in that region. And these are some of the results from the last few months. You can see over a very small region, and this picture in the corner is some evidence that we are seeing those electrons go off. So I have one more month and a lot to do, but I think we're going to get there. So having shown you 2 areas of research, I just want to now tell you 2 stories that have shaped my own thoughts about the topic of women in science. The first comes from my time as an undergraduate student at the University of Notre Dame. I'm a proud Notre Dame graduate. I will admit I've been up in Jerusalem at 3 a.m. more than once watching them play football on TV. It's been a very good year. They're undefeated at home. Notre Dame is a Catholic university, and it went co-ed is the phrase we would use in English, which means it finally got around to admitting women in 1972. I think it was founded in 1840 something. But in 1972, they decided they should admit women. And I went to the university in 1977. Women were limited at that time to 25% of the population admitted by quota. It has slowly worked its way up to reasonable parity. And of course, there were very few of us in science and engineering. Although the overall welcome at the institution was very warm, there were certainly some professors and a number of male students at the time who did not believe that women belonged at the university, nor did they believe that women belonged in science or engineering, which was my field of study. I have a very clear memory, my sophomore year, my second year, of walking into an electrical engineering laboratory. And one of the first things we were asked to do, electrical engineering keeps coming up. I don't know what it is about it, but this was my electrical engineering lab. And one of the first things we were asked to do was to select our lab partners. I looked around the room. There were probably about 2 or 3 women. Thank you. 2 or 3 women out of the 35 students in the class. And my first thought was, I don't want to partner with any of them. Right? I realized pretty quickly what I had just thought. And I realized that I had internalized, right? It was like seeing a mirror for a second. I had internalized what society in many ways had been telling me my whole life. That the women were not quite as good, probably, right? That we weren't quite as smart, that we were going to have to work a little bit harder. And if it was bad enough for me, then putting 2 of us together was going to be, right, even worse. So I didn't want to go there. But I realized that if I was thinking this way, I should not be surprised if many other people were. And that experience, which probably lasted 5 seconds, right, before I went through all of that, has stuck with me to this day. And it does represent, I think, the depth of the challenge that we still face. The second story is also personal. My mother was the first in her family to go to college. She graduated in 1940 from a small woman, again, Catholic college. World War II, she worked briefly as a teacher, married my father when he came home from the war. They raised 3 children. She loved ideas and travel and books and taught us to love them as well. But when I was a student in high school in the 70s, my father had died when I was younger, so it was pretty much my mother and I left alone at home. I remember her telling me in high school that I should take a year of typing. Right? They offered a short course for the college-bound, but then there was a year that they offered. She got really good at it, right? She told me I should take a year of typing for 2 reasons. One is it would be a good thing to know, and she was absolutely right. Right? It has been a very good thing to know. But the other was, and I remember her telling me this very clearly, she said, you can get a very good job as an executive assistant if you are you're smart. She knew that. She said, you're smart, and if you can type, she knew shorthand was on its way out. If you're smart and you can type, you can get a really good job, right? I was at the top of my high school class. I was clearly going to go to college, but in my mother's world, there were 2 things that were true. One is you needed skills, and that is still very true. And the other is that men were going to be in charge, right? And that's less true, but still sort of true. The personal side to the story, I think, was that she was able to go to college, right? Because she had 2 aunts. They were often called spinster aunts at the time. They had not married. They'd gone to New York, had executive assistant jobs for important men, and they had put her and her brother through college, right? So it was a personal experience of a time that was reflected in just a view of the world. Now, my mother wanted all good things for me, right? I have no doubt about that. And I was a full professor before she died. She supported me and took great pride in all my professional work and success. But I tell this story because it reminds me really of how far we have come in just a generation, right? In terms of routine possibilities for women and the way we now question our assumptions, right? So a lot has changed. Nancy Hopkins said it as well, and it's probably what you're going to get a little bit from my generation. A lot has changed in 30 to 40 years for women as a large group. Right? That doesn't mean we don't have the particular story of a Marie Curie or a Rosalind Franklin. These are important stories, but collectively we've made a lot of progress. It doesn't mean we don't have a long way to go. So let me conclude then with just a couple broad thoughts on the topic. I do believe that we have to see the topic of women in science, engineering, any field where there have been historical restrictions, assumptions that are limiting our participation, through what we heard about, through a variety of eyes. The eyes of science, right? But also the eyes of culture and the eyes of history. Science, I am absolutely convinced, benefits from the open participation of all, right? Society benefits from the open participation of all. And despite our prejudices and our historical assumptions, which are quite deep, intelligence, talent in all areas are gifts that are clearly widely shared, right, broadly given, and we only limit ourselves when we don't recognize that and take full advantage, right? So there's this collective commitment, I think, to that. I think the goal should be an environment where you really are accepted for who you are, right? Gender, color, orientation, religious tradition, you name it. You can be who you are, and then are provided opportunities and ultimately then evaluated based on the particular gifts that you have and the work that you do. This can cut both ways. I mean, I remember growing up and people saying, well, you're good at math, you should go into engineering. I should only go into engineering if I enjoy engineering, right, or science, which I happen to do. But the opportunities need to be there for everything. And one of the things that I love about being in science, like mathematics, like music, is that it's a language, I think, that bridges cultures and bridges people. It's an international activity, and for me, that has been really one of the great privileges to work with colleagues all over the world. I love the stimulation about thinking about something new every day, right, and discovering something new. And I love the challenge of sharing that with young women and men, which is what makes the teaching part of our jobs, I think, such a pleasure. I think we also have to look at this with the eyes of history and culture and remember that we are part of both, right? And that the roots go extremely deep for all of us in ways that we don't always recognize, unless you have one of those moments like I had in the engineering laboratory. So if you have not seen it, I want to refer you to a recently published study in the Proceedings of the National Academy of Science. This came out just this past fall, right, August. You see the authors there. And the title is Science's Faculty Subtle Gender Biases Favor Male Students. And we can just quickly read this together. In a randomized double-blind study, so 127 participants, science faculty from research-intensive universities rated the application materials of a student. So this is one of these same resume, two different name studies. Randomly assigned either a male or female name for a laboratory manager position. Faculty participants rated the male applicant as significantly more competent and hireable than the identical female applicant. These participants also selected a higher starting salary and offered more career mentoring to the male applicant. The gender of the faculty participants did not affect responses, such that male and female faculty were equally likely to exhibit bias against the female student. Mediation analysis indicate the female student was less likely to be hired because she was viewed as less competent. So it didn't matter whether the faculty doing this were in physics or biology, I believe were the two areas, or whether they were male or female. Now in 2012, this may disappoint us, but I suggest it probably should not surprise us too much, if we're honest. The roots of these assumptions that prejudge individuals based on their gender go very, very deep. They are millennia deep, right? And I have found Israel a very good place to reflect on this long history because you are so steeped here in millennia of history. So the roots of the challenge are based in physiology, they're based in religion, culture, they're now based in the media in all kinds of interesting new ways. We put a new face on it. And so in the assumptions that we're still making about each other. So going forward, we have to be reflective about this and passionate. And you can really be both, I think. You have to be persistent, you have to be in it for the long haul, you have to be knowledgeable, and I thank the people providing data for us for that. You have to be fairly courageous at times, you have to be disciplined. But you also have to live your particular life in a time and a place and a culture, right? It is your only choice, while being aware of that history and that culture and being willing to question it and to challenge it. So like the two stories, I think we have to be cognizant of how far we have come. It reminds us it can change, progress is possible, we're seeing it, it's real, gives you the strength to persevere, but we also have to be challenged by the road that's still ahead to travel. Thank you.